chaps. This is week 13, I think it is. And if this is week 13, that means next week you guys are actually going to be in school, which is quite exciting. So this week we're going to learn a little bit about magnets, and I think probably a little bit about electricity, electrostatic forces, okay? Remember, we're in the topic of forces now, okay? Last week we discussed gravity, and yes, our next force is magnets. And I just want to show you this really cool thing. I don't know if you can see that, but there is a little paper clip here. Can you see the paper clip? Held by a string, and it's actually floating in the air. It's quite cool. There's no kind of magical or editing here, okay? And it's simply magnetic force, right? There's a strong magnet over here, and you can see that that keeps it there, okay? I can just pull it down, and it eventually will fall, okay? But when I keep it close to the magnet, hovering in the air, isn't it? Cool, okay? So magnetic force can be, in fact, stronger than the gravitational force. In this case, it's stronger, or at least it's equal to the weight of the clip. And one thing I like to do when you guys are here, to show that this magnetic force, okay, it can go through paper. In fact, can go through many things. Okay, it's not affected by it. So that is quite cool. Okay, now, you know, often if I ask you what can be a magnet, often people will say all kind of metals. All metals are magnetic. And that, in fact, is incorrect. There's only three kinds of magnetic material. Okay? First one is iron, which makes you think that all metal are magnetic. The other one is cobalt and nickel. Okay? I will tell you quite a few things now, and then we'll make notes for it on the board. But iron, cobalt, and nickel are the only magnetic elements. Okay? Steel is also magnetic, but steel is what we call an alloy. Alloy is a mixture of metals, and steel is an alloy that has iron in it. So it's the iron inside the steel that makes it magnetic. Now, what is the difference between a magnet, magnetic material, and a non-magnetic material? Well, the thing is that a non-magnetic material, okay, is basically any element that is any other elements other than these three elements are not magnetic. They're not magnets, and they're not magnetic, and they can't be a magnet. They won't be attracted to a magnet, okay? And they can't become a magnet. Magnetic material is one of these three elements, iron, cobalt, and nickel. And they can become a magnet, and they're attracted to a magnet, but they're not magnet yet, okay? What does that mean? That means, I'll give you an example here. I've got iron, an iron nail, and I've got some paper clips, okay, which have iron. It's steel, so it has iron in it. They don't attract each other. They're both magnetic, but they don't attract each other. But they can become magnetic, and we'll talk about how we do that in a bit. So it's important to know the difference between a non-magnetic material, magnetic material, and a magnet. Okay, so we understand the difference between non-magnetic and magnetic material, but what is the difference between a magnet and magnetic material? Okay, well, this is a magnet. It's made out of iron, so it's magnetic material, but it's also a magnet. That means it will attract another magnetic material, okay? Right? Where a magnetic material, as we said before, they can become a magnet, but they don't actually attract each other. So if you were here in class, I would have done a little experiment with you. I would have given you three materials, okay, A, B, and C, okay? One of them is a magnet, one of them is magnetic, and one of them is a magnet, one of them is magnetic, one of them is a non-magnetic material. And you need to figure out how can you separate between the three. Okay? How can you tell which one is a magnet, which one is a magnetic material, and which one is a non-magnet? Okay? And what you can use is a magnet. Okay? So that's going to be like the homework or the classwork for this lesson. Okay? You've got these three materials. Okay? Imagine you've got three materials. You don't know which one is which. You've got a magnet, and you need to decide which one is a magnet, which one is magnetic, which means it's not a magnet, it's just magnetic material, and which one is a non-magnet. Okay, so that's our classwork for today. Now, I did tell you that we can magnetize a magnetic material. What does that mean? Okay, we take a magnetic material like this, which is not a magnet, and we can turn it into a magnet. And I think some of you would have done that in the past, okay? So I'm just going to lower the camera.